Hello and welcome to yet another video. Today we have an Asus Prime Z390-P. So let's open this up. So this board came to me for no boot. Don't have any more information about how this came to be. I have repaired one of these before, but I don't really remember what the problem was with that one. So we're going to be starting with our usual checks, I think, just to be very sure. But the previous owner said that this board did start up, but there was no boot. So let's get a multimeter on here. So let's check our resistances. Starting off with CPU 12 volts. That looks fine. Let's see for 12 volts directly into the CPU. And this seems to be fine as well. So let's go into 12 volts. This is kinda low. 200 ohms. Okay. This is, I think, 5 volts. This looks fine. This is 3.3 volts. This also looks too low. 3.3 volts with only 30 ohms. Okay. 5 VSB. Looks fine. PS on. Looks also fine. Okay. Because the 3.3 volts was kind of low, I would go around the SIO and probe some big capacitors to see if the SIO is fine. But as you can see, around these capacitors, there seems to be no problem. So I think there will be a standby voltage issue here, but I'm not too sure what it could be. It could also be a dead PCH. This is the PCH. 25 ohms seems okay, directly measuring the PCH itself. So I don't think that the PCH is going to be our problem. Let's see for the passive power consumption if that already has a problem and if that already is going to tell us if there's something shorted or not. So the socket looks very clean. Socket isn't a problem, thank God. I will have to look up what kind of CPUs go into this board. I think it's 8th gen Intel CPUs, but let me have a quick look. Okay, just looked it up. It's 8th and 9th gen Intel. And what we have is a G5400 for that. Let's plug that in. Let's get one stick of RAM into here. Let's also get a DDR tester into here. So, and let's see now for the passive power consumption. 150 milliamps, that looks pretty decent. Do we have post LEDs? I don't think we do. Don't think we have post LEDs. So we will be looking at the power consumption mainly and at the DDR tester. So let's get a speaker also into here for better debugging. So let's press the power button. There seems to be no reaction to the power button. I just thought there might be something wrong with my power button, but using just pliers to short these two contacts at the very bottom, there's no reaction, nothing. So the board doesn't even turn on like that. So what I would try is to reset the BIOS, definitely, when you don't have a condition where you can't power up. So that's a clear CMOS header right here that we can press. And also you need to take the battery out, disconnect the power, and you can also short the battery contacts. And let's now see if that has helped. Still no reaction to the power button. Okay, let's now see if we have actual voltage on the power button pin. We would expect around like 3 volts, 3.3 volts. And we have 3.3 volts, okay. So the 3.3 volts from the SIO is definitely there. But it seems to be that there has to be a problem around the SIO. Most of the time it's a problem around the SIO if the power button, if the board doesn't react to the power button. So let's see if there's maybe something knocked off around there. And then go from there. So let's see if we can see any damage here. So far so good. So far, I cannot see any damage around the SIO. Okay, so I don't think that the problem is going to be located here, at least for knocked off components. So I would say I will go around the board looking for knocked off components if there's anything like that, because there could be like a missing signal somewhere because of a missing resistor or something like that. If I found anything, I will get you back into here. And if not, we will be going over to testing some voltages and seeing if the SIO actually sees that the power button is being pressed. So I wasn't able to determine any physical damage. So let's now see if this board reacts as soon as the CPU voltage is not attached anymore. But that doesn't seem to make a difference. Okay, so that didn't change anything. One more thing I want to try is take the CPU out and see if that makes a difference. Nope, that also doesn't seem to make any change. So one thing you can do in this case is to manually power the board on. I've told that before that many people don't like doing that because it's actually like kind of dangerous regarding having something shorted. But we're going to try that. We're going to be pulling P's on low by ourselves. Okay, there's almost no power draw. There's only 300 milliamps, so there's basically nothing turning on this board. Okay, so that didn't do anything for us. Let's see if the 3VSB is running on this board or not. And the 3VSB or the auxiliary 3VSB is running, as you can see by the board there. So it seems like we need to have a closer look at around the SIO area and have a look at the pins for power button in, if this board actually sees that or not. Okay, but before we go on to the SIO, let's see if the PCH voltage is actually running or not. Yeah, PCH is running. Let's see for some more voltages. This is 3.3 volts. Let's see. This is the adjust for the 3.3 volts. This is the 5 volts coming in. 3.3. 3.1 around the SIO. That seems kind of weird. 3.1. 3.3 volts around the BIOS chip is also present. So most of the passive voltages that I would expect are present. So let's go now into deeper dive onto the SIO. So there's a few things I want to check. What I want to check is this 1.8 VA that is coming into the SIO, if that is present. But this might not be connected to anything. And what I also want to check is power button in this pin 61, and I want to see if that has anything on it and has a reaction as soon as we press the power button. And then we can also check S3 and S5 states to see if any of those have any voltage on them, just like these S4 states. And we will also be able to check the power OK ones, but I think these come later, the power OK signals, when we already have P's on. So let's first check with the power button. So let's go on to pin 61 and see what that has for us. So we need the voltage on that resistor right there. This is 3.3 volts. Yes, on both sides. And now I will need to press the power button and see if it actually goes low at the SIO. So, as we can see, the power button does react. So as soon as I press it, it goes down. So there has to be something else around the SIO. So let's see for the sleep states if any of those go high as soon as we press the power button. So sleep state S3 is supposed to be up here. And we do not appear to get that. So there's no reaction when we press the power button. So S3 is not going high. Let's see for like S4, but I don't think that these should be high when there's no PS on yet. So I think that is correct that they do what they do now. So I quickly chase down the PS on pin, and the 5 volts do get all the way to the SIO. So the PS on voltage goes all the way from 5 VSB close to the 24 pin, goes to the SIO. So that also isn't a problem. So it does have PS on. There's a continuous path for PS on to pull it low. So it's been quite some time. It's been about 2 days since I worked on this board, and I've spent another, I think, 4 or 5 hours on this board just confirming what I've found, because this problem goes quite deep, and finding out what the cause of the problem was. And I'm pretty sure I found the problem. I can't tell 100%, but let's go through it step by step. So what we know is that we have no reaction on the power button. So what I want to check is, let's show you on the board view. So what we want to check is power button in and power button out. There's these lines, power button, IO power button, that go to the SIO, and then there's also the incoming power button from where we press the power button at the front with the 3.3 volts. So let's check these signals here. This resistor is connected to 3 VSB and goes to here into the SIO through 1K resistor. So let's check the 4th pin and this resistor. So this is now the resistor we've been talking about, and I'm now pressing the power button, and as you can see, it is going low. And if we check the other side of the resistor, same thing happens. So on the side of the SIO, this is definitely working. Let's now check the output side going to the PCH. And now we can see we have this resistor where the power button comes from the SIO and then goes through 49 ohm resistor, goes all the way into the PCH. This is not fitted, but goes into the PCH there. So let's look at that resistor. So this is this resistor right here. And if we check here, we get 3.3 volts. On this side, we get the 3.3 volts. And now if we press the power button, the signal goes low. Release it, goes high. What I've also checked, just to be sure that there's no broken trace, that the power button goes all the way to the PCH. Let's look at the PCH in the board view where it comes to the signal. The signal travels all the way down to here to this pad where this component is not fitted. So the lower pad. So on this pad right here, this is the incoming signal. As you see, we have 3.3 volts. And upon pressing the power button, it goes low. You see, it goes low, goes high, goes low, goes high, as soon as I press the button. So that signal also travels all the way to the PCH. We're able to confirm that. And now the next thing is for the PCH to react. I want to show you that via a schematic. So now we are on a schematic of a Z390 board. This is a Z390-A from Asus Prime, but it shouldn't matter because we just want to go over the startup sequence that we have here. What you can see is that each of these signals has a number close to them, which resembles the order in which they start. Let's search which one is the very first signal coming in here. So what you can see is the AC power on switch. This is basically that your power supply is connected. From that you have your 5 VSB, 3 VSB, all of that is coming in. We have all of that, we know that. And then after that we have sleep states. Sleep state S4, sleep state S3. This is 4 and also 8 and 9. So keep the 8 and 9 in mind. This is the more important thing. We have RSM reset. This, I have checked this. We do have this. So this is number 4. And then we have number 5 is the power button, our normal power switch that we press. It's the PS in that goes into the SIO that you can see here. And this is present. We know that the PS in on our power button does work. So what this now gives, this gives a reset signal out to the PCH, or give the power button. And I think it should be OKB-RST. This is the reset signal that we've checked from the power button that goes out. And oh no, this is the power button signal. Yes. Oh, power button out. This is what we need. We have this one. So it's not KB reset, but it's the 6th one here, the O power button. This is the one that we need. And this is going out to the PCH, and we know that this is going out. And then the PCH is supposed to respond with SLP-SA, and then also with the other sleep states, with 4 and 3. And what you need is the RTC section for the PCH to be good, but I've checked the resistance on this RTC section, and that there's also the 3 VSB going into the RTC section. So that is also working. And I've also checked DP power OK. I've checked that this is present as well. And I've also checked the oscillators. That's what you also seen before, that I've sorted another oscillator because I thought one was faulty, but the oscillators are both fine. So we have all of that for the PCH to work, because all of the other stuff is just things that come later. As you can see, there's 7.2. There's 17 SMM power okay, the ME power okay. This is not fitted on our board as far as I know. And yeah, so what we need is the SLP4 and the SLPS3. I think on our board they're called a little bit differently. They're called S4 and S5, but I'm not too sure. But we're going to have a look at S3 and S4, I think it's called on the board view. So let's go over to the board view. So on the board view now, we have the signal, which is called OLSPS S4, as you can see in the top right. And it's only connected to the Super IO here, and connected to this 300 ohm resistor right here. And this 300 ohm resistor then on the other side connects to the PCH. So we expect that this point here gives out a high signal for S4. So let's check that on our board. So directly above the capacitor is our 300 ohm resistor, so this one. And we can see there's nothing, and when trying to press the power button, we still get no reaction. And from the other side, that is the PCH side, we also have nothing coming out of there. So S4 is not present. Let's now check S3. And S3 is coming in through this 300 ohm resistor. So it's very similar to the S4 state, where it's connected here to the SIO, and then here connected through 300 ohm resistor, and on the other side is then connected to the PCH exactly there. So we expect something on this side here. So let's check that next. So we have this resistor right here on top for S3, and pressing the power button, nothing happening. Nothing going high or low from the PCH side. Nothing on this side, obviously, because this is an incoming signal and it should be coming from this side. So we do not get the S3 or the S4 state. Let's go back into the schematic once more. So with that, we now know that this signal and this signal isn't coming out of the PCH. I've checked once more, and this is not fitted on our board, the ME power okay, the one that you can see lower here. So this is not of our concern, but of our concern is this and this. Let's see if SLP A is fitted on this board. I'm not quite sure if that is connected here. Let's see on our board view. So SLP A, let's see, SLP sleep state here, SLP A. And this, as far as I know, is not connected. Yep. So we have as you can see in the top right, SLPA, and this is only connected here. There's nothing else connected here. This is only via the PCH itself. So this isn't used on our board. So SLPA is of no concern for us here. And now there's almost nothing left at this step that we have the 8th and 9th step. So this is not there. The LAN isn't really necessary for us. The ME power is not fitted on our board. So that this is also not necessary for us. This is present. We know that. Well, let's check that. I've checked that only on my own, but I want to show you this as well. And here we have the signal. It's called SDPWROK. So let's see. This is only connected to the PCH. This is nowhere else connected. So this isn't used also. So we couldn't even trace this if we wanted to. As you can see, there's only the PCH and there's nothing else connected because these parts here are not fitted. This one or this one, these are completely not fitted on the board. And this is just a test point on the back side. So with that, it only really leaves one thing, which is the PCH itself, which could be the problem. Because all of the incoming signals from the SIO side is good, and I cannot see why the PCH wouldn't react to the incoming power button. Because the RTC section is fine, it all works, it has the 3.3 volts working with the SIO, and the all of the incoming signals are there. So let's check the PCH itself once more. So we now look at the 1.05 volts of the PCH. So if we have a look at this inductor, we have 1.06 volts. And I also want to show you that the PCH uses some more voltages. The PCH also uses a 1.8 volt that is connected right there. As you can see, this is present. And it also uses 3 VSB that is somewhere here, but 3 VSB is present on the board. We've checked that multiple times before, so I don't want to check. We really don't need to check that again. But the 1.8 volts was something new for me, so we were able to check that as well. And now let's go into resistance mode and check the PCH power supply. So on the output side, we can see low ohms, 16.3 ohms. And I've seen that before, and I thought it would be fine, but I was told online that Z390 should have like 30, 35 ohms and above for it to be okay, and 16 ohms should be too low. So what we now want to do is I want to inject power into this board. So about 1 volt I want to inject. So we have these tweezers where my power supply is connected to, and when we probe them with my multimeter, we see there's 1 volt on them. So we now go onto the power supply and let's see. It draws 50 milliamps only at 1 volt. So this really isn't conclusive, sadly, because we probably won't see this under a thermal camera as well. So the resistance is too low, but the power draw and the power consumption sadly isn't really telling us anything. So, but I'm pretty sure that our fault is the dead PCH here. So, showing you once more, trying with the thermal camera out here. If you can see any hotspot. But there's no hotspot on the PCH anywhere. But that was to be expected because the power draw is just way too little with 50 milliamps. But I'm pretty sure that the PCH is dead, because there's nothing else left and the resistance is way too low. With 16 ohms in a cold state, because this PCH is completely cold, there's no draw, no power going through that right now. And 16 ohms for Z390 is too low. So this is basically how we were able to determine that our PCH is 99% sure that there could be another reason, but I'm just not able to find anything else. I've spent hours on this, analyzing the startup circuit of this board, measuring out things, trying to figure out what signal comes after which one, and this is all I can find. One more quick thing I forgot to mention is that I did flash the BIOS with the newest BIOS from the Asus side, but that also didn't make any difference. And yeah, I hope you learned something in this video. I hope you enjoyed the repair or the diagnose of this board, at least, because I won't be able to change out this PCH. I don't have the proper equipment for that, and it's really not worth it. If you look at this money wise, this board is like 40 bucks on eBay, working condition. So this really isn't about the money, but about the experience and about the learning here. So if you liked the video, hit the like button, subscribe so you don't miss any new videos. Thank you so much for being here. This was Mainboard Medic. Thank you very much, and goodbye.